All right, guys, welcome to the second and final section of week three, distant learning probability. We're doing samples and populations. Now, this is a little bit different from probability. Excuse me, kind of got the hiccups, but I can power through. It's okay. It's a little bit different from just finding probability of certain things because we're looking at the bigger picture now. We're going to be looking at the populations of things and finding probability based on those populations. I think it's pretty cool. It's not super mathy, which is great for you guys. So first, what is a population? Well, a population is an entire group of people or objects. So like the human population is all the people, everyone. But then you could break that down into boys, girls, ethnicities, the race, right? You could break those down into many different aspects, but population is the biggest thing. So don't write this down, but we're going to talk about it. In 2002, there were claims that chronic wasting disease, chronic maybe, or mad elk disease was spreading westward across North America. In order to evaluate these claims, the elk population had to be tested, right? We need to evaluate these claims, see how true they are, and see what percentage of like the elk had it, right? So surveying or testing every member of a large group can be difficult and impossible. Instead, researchers often study a sample. Now, they did not go and study every single elk. I don't know how many elk are in Northern America, but there's a lot in North America, right? There's so many. There's like a million probably. They're not going to go testing a million elk. How are they supposed to catch them all, first of all? So instead, they're just going to take a sample. So they're just going to pick different parts from the North America and pick a sample of them and figure out what percentage have them. So a sample is just part of the population. A sample can be used to make conclusions about the entire population. It's kind of like that example we did. Well, if it rained 1 out of every 6 days, we can expect it to rain 5 times in May. Remember, we did that problem? The sample was the 6 days, but the population was the whole month. So a sample is just part of the population, and it can be used to make conclusions about the whole population. So let's identify what the population is and the sample. Example A, the students in school and the students in math class. Well, the school is the entire thing, and the math class is that very specific amount. So school is the population, and class is the sample. For example B, grizzly bears with collars in the park or grizzly bears? Well, the collars are the sample, that's the smaller amount, and all the grizzly bears in the park, that's the whole amount, that's the population. Third one, 150 quarters or all quarters in circulation? Well, 150 quarters is just part of that amount, so that's going to be the sample, and all the quarters, every single amount, that's the population, right? Because it's the bigger amount. The bigger amount's the population. So all books in the library, I can tell you right away, that's population because it's all of them. Or 10 fictional books. Well, that's the sample because that's the smaller amount. So hopefully you guys can kind of see the difference between population and sample. Now, we need to talk about biased and unbiased. Some samples are biased, some are unbiased. An unbiased sample is representative of a population, it's random, and it's large enough to prove accurate data. A biased sample, if something is biased, it's not representative of the population. One or more parts of the population are favored over others, and it does not fairly represent. Maybe it's not big enough to represent. So you guys can go ahead and write that down, but I'm gonna move on. Feel free to pause the video. If a sample is biased, or a sample is biased if the results may be influenced by who or what was surveyed. So biased is no good. Determine whether the sample is biased or unbiased. Explain. An employee of a phone company randomly chooses 80 customers to ask whether they are happy with their service. Okay, first off, the guy's choosing customers of the phone company, so that's the right people he's picking. He picks 80 of them. That's a lot. And he randomly chooses the customers. He's not specifically picking people, right? But what does it say? Let's see, randomly choose 80 people. So he's just asking whether they're happy. It's not that the people are already happy. He's asking whether they're happy. So this is unbiased. It's fair because the sample's random. There's a lot of people and he's picking the right amount of people. But what about the first 25 students to arrive at school? We want to find out how they got to school. Well, it could be random, but what if they showed up on a bus and they all showed up at the same time? Then you would think the first 25 people all take the bus. Everyone must take the bus then. You think everyone must take the bus. But no, the sample is biased because it's likely the first 25 students arrived by the same method, such as a bus. That's very possible. So that's biased. Next, determining whether conclusions are valid. To determine whether a conclusion is valid, it needs to be unbiased and it was from the correct population. For example, if we're doing math stuff, you can't take population from the science class. That wouldn't make sense. We need it with math. It has to be with math, right? That's like saying the guy checking to see if they're happy for the internet service or the phone service. If he was going to Walmart and just picking random people, no, they might not even have the right internet or phone service. So it needs to be from the correct population. So, for example, Mary conducts a survey to find out which animals at the zoo are most popular amongst visitors. Determine whether Mary's claim is valid. So 30 sampled 30 visitors outside the monkey house. And she asked which zoo animal is your favorite. 10 people said monkeys, 8 people said bears, 6 people said lions, and that's only, let's see, 24. So there were a couple other random ones that they didn't pick. But she realized 10 people said monkeys, so monkeys must be the most popular animal at the zoo. Is this valid? What's the answer? No. The answer is not valid because Mary picked 30 visitors outside the monkey house. You can't pick it outside the monkey house. More people are going to pick monkeys because they like monkeys. It's outside the monkey house, right? So instead of picking outside the monkey house, she needs to pick somewhere else at a random spot. So the conclusion is not valid because the sample is biased based on the visitors standing outside the monkey house. They might be more interested in the monkeys. So for this next one, Jed conducted a survey to find which zoo or which animals at the zoo are most popular. So he picked 50 visitors at random throughout the day. Asked the favorite zoo animal, concluded lions are the most popular. 12 monkeys, 18 bears, 20 lions, right? So since lions had the most, we can conclude that this is valid. Yes, because the sample's random. Didn't pick people outside the monkey house, picked them randomly throughout the entire zoo, right? And picked 50, which is a lot. So therefore, this is random, so the claim is valid. The website consists of 400 pages. In a random sample of 20 web pages, 7 of the pages have broken links. Predict the number of web pages that may have broken links. So now this is where it gets mathy. 400 pages, but are you going to go through all 400 pages and find out which ones have broken links? No, that's a lot. We just want to find the number of broken links. So instead, we're going to take a little sample of 20 web pages. We find out 7 out of the 20 of them have broken links. So the probability is broken links in a sample over the total pages sampled. The total number of broken links or total number of website. So here we can say there's 7 over 20, right? If there were 7 over 20 of the web pages that were broken, we need to find how many total, right? So 7 over 20 is the one probability for that little amount, but we need to do the bigger amount. So we make a, what's that called? I can't think of the name right now. Proportion. We make a proportion. So 7 over 20 equals x over 400. 400 is the total number of pages. So we are going to cross multiply or do a different method, and we end up getting, let's see, 140 as our answer. So the way I did it, I did 7 times 400, and that has to equal 20 times x. So 2800 has to equal 20x. So that means we need to divide by 20 to both sides to get x, and 2800 divided by 20 is 140. So if there were 7 pages broken out of the 20 pages they sampled, you can predict that there will be about 140 pages broken out of the total 400, which is kind of a lot. That's 35%. All right, we're almost done. Determine whether you would survey the population or a sample. The manager of a store wants to know the average age of the store's customers. Okay? The entire population is large. it would be difficult to find out the age of every single customer, right? Because it says the manager wants to know the average age of the store's customers. So we cannot pick every single customer. If you go to a Walmart, maybe not right now because social distancing, but probably right now. So there's so many people in the store. You cannot ask the age of every single person. First of all, that's rude, and second of all, it's just too much. So it makes sense to use a sample here, right? So we would want to use a sample. Determine whether you would survey the population or a sample. So we would do a sample. The manager of a store wants to know the average salary of the store's 8 employees. There's only 8 employees. That's not that much. So it does not make sense to use a sample. It won't be as accurate. You can evaluate all 8 customers and take the mean or the average. You can do that. Guys, that's it. So the homework is on big ideas. I'm not sure why it says 10.7. I believe it was 10.6, right? But anyways, 1 through 11, 20 through 24. All right, challengers, I'll see you later. You guys have a great rest of your week. Thanks for tuning in, and I'll talk to you guys soon. See you, challengers.